what is the applications of the additive manufacturing in the investment casting process. So in the investment casting process, we have to make the mold design like this. If you will make the mold design like this, sometimes what will happen, the very complex profile will be there. So those complex profile, using conventional process, it will be very very difficult. But if you make the like a mold like this using additive manufacturing process, so what will happen, this mold can be used in the different different areas where we can use the casting process. So here we can use the first design in assembly of this mold, and then from that mold we can make the whatever the exact product is required. So that's why additive manufacturing process, wherever the complexity of the part will increase, it can be very easily used as compared to other conventional manufacturing techniques. So here in investment casting, so as we know that 3D printing process is day by day increasing, so applications, so that and pattern making for investment cast also becomes very significant for the artisans, engineers and industrial professionals. So users are able to test, design, iterate faster and then quickly produce short runs while reducing the expensive tooling and the long lead time. As we know that during the conventional manufacturing process, when the customer will give the orders, and after that they have to produce the first mold, and after that once the mold is ready, then only they can go for the manufacturing of the any part. So in this production of the part and delivering the part to the customer becomes very long. So why? Because they have to make the mold, and then from that mold the product will be manufacturing. So manufacturing of the mold using conventional techniques, it is time taking procedure. But in the case of the additive manufacturing, once you have your CAD design is ready, so you can go for the manufacturing of the whatever the design model is there. So as per the design model, one can manufacture. That's why in this additive manufacturing process, the lead time is reduced sharply compared to conventional manufacturing techniques. So this 3D printing process enables company of all sizes to speed up innovation while reducing the cost. So I will be discussing about what are the different steps which is required for the manufacturing of the investment casting mold design using additive manufacturing process. So first, in the first step, you have to start with the CAD design model. Yes, so in that first when you are placing the model into a build plate, then you have to orient the whatever the part is there, so that it will minimize the support structure as much as possible. Why? Because support structure is not part of our product. Anyhow, that support structure has to be removed from the main part design. So that's why this is very very important to remove the part from the support structure from the part, so that quality and then whatever the exact structure will be there, that structure will be useful. Similarly, print your model with minimum infill density. So this additive manufacturing, the benefit is that you can build or you can print your material with the less than 10% infill density also, and also shrinkage compensation will need to be applied to the STL file format itself. Similarly, a layer height of 0.1 to 0.2 mm is ideal for this application. As we know that generally layer height will be 0.2 to 0.1, 0.3, 0.4 up to 4 also, but beyond that 4 it will be difficult for the defect free product also. So for that purpose 0.1 to 0.2 will be the optimal layer height thickness. So now coming to the in the step 2, you have to perform the post processing operation. Once your CAD product is manufactured, or like casting is product manufactured, then you have to go for the post processing. In that post processing, first you have to deep and spray the polishing are the two method for the post processing, and you have to use the 800 grit side and paper to remove any surface defect or any seams on the printed part. When finishing is done, so then be sure that remove any debris or dust from the surface of the whatever the final product will be there. So those you have to ensure it, and attach and wide or any similar material to the suspending to the point out any post processing is completed. So those things have also you have to ensure it. Similarly, after that you have to dip the printed pattern in the isopropyl alcohol for 5 to 10 seconds, and it may be kept for the after suspension the print it will allow for drying for 20 to 30 minutes. Then you have to place the object whatever the final part in the vacuum so that proper curing will be taking place, and or you can place in the convection oven set at 440 degree temperature for 1 hour time period. So depends upon the proper, you have to ensure it the proper curing is taking place, otherwise it may prolonged. Maybe a proper strength is not there, so that time directly you are using, so maybe part do not have the strength, so failure of part may be taking place. So in the third tree, so you have to ensure that whatever the part tree of the printed product will be there, though part tree we have to remove. Part tree nothing but the subsections of the investment casting product will be there, so those product part you have to remove it. So that here I have mentioned that you have to remove any cup to the part of the casting, and then ensure that metal flows smoothly and evenly into the part surface. Similarly, you have to attach the part to the cup with the wax bar and a screw, which will serve as the channel for metal flow during the casting process. Similarly, you have to attach smaller wax pieces to the inner area of the part for the even flow distribution of the materials, and also you have to attach one smaller torch may be used to the final assembly to eliminate any holes in the screw or in the final part of the tree. And after that once this all are done, and after that you have to perform ceramic coating or dipping in the ceramic liquid will be there. So in that ceramic cell will be serve as the final mold for the casting once the printed material has vaporized during the burnout process. So this will create the first mold by alternative immersing the part tree in the ceramic slurry, and then finally extremely fine silica compound. Generally after at least 15 coating process, because maybe you have to apply this one dipping process is done. After that you have to apply multiple time of the coating over the whatever the tree surfaces are there over that, so that proper thickness of the coating will be taking place. So once the proper thickness of the coating is taking place all over the surfaces, so what will happen once you will remove the part tree, so in that vacuum inside hollow will be created, and that hollow will be the final cavities. In that cavity whatever the part you are going to build, that part will be pulled with the molten materials. And then it is also you have to ensure that means each coating completely dry and before repeating the second operation. Yes, and after that you have to ensure it whatever the wax pattern you have made, so that wax pattern has to be burned out, so that whatever the final burnout wax will be there, those liquid will be removed out, and then inside hollow cavity will be created. So it will be maybe ceramic cell will be there, that ceramic cell will be burned out and printed material will be created inside the mold. and you have to place the coated part tree assembly in the kiln or furnace, so that a proper drying will be taking place. And then you have to keep maybe 1100 to 1200 degrees centigrade for the approximately 1 hour time period. And after that, printed material has burn out and allow the cell to cool for the completely for the certain time duration. And after that, you have to perform the casting. Now it is the final turn when you can perform the casting process. So in the casting process, you can pour the whatever the molten material we want, so that pouring after pouring, and then whatever the cavity of the casting will be there. So though cavity casting, as per the cavity casting, the final product will be made. So if any ash or debris remains in the cell to be burned out, and similarly sometimes preheating may be also done before pouring in the final materials, so that any like impurities or maybe sometimes many maybe suppose liquid is present there, moisture is present there, so that it will be completely removed out. And then also you have to ensure that temperature may vary, so for that you have to maybe heat it around 500 to 1000 degrees centigrade, and then pouring of the molten material into the cell while the cell is in still hot condition, and you have to allow the poured material for the certain time period, so that proper cooling and solidification will be taking place. And once proper solidification and cooling taking place, and after that you have to remove out those your printed coated sample was there. So in this way you have to clean up the part. So for that you have to remove the any ceramic cell, screw or any other part which is associated required during the pouring process. So and after that you have to perform the cooling process, so that will lead to the final dimension there itself. You can get it the whatever the part is produced. So after the part has completely cooled, it is to be removed from the ceramic mold, and then a screw of the same pattern will be created. So this can be achieved through sewing, cutting, sanding and blasting, or plasma cutter. Means whatever the uneven surfaces will be there, so those uneven surfaces will be removed out, and the quality surface finish will be performed. So coming to the now we will discuss about the design and fabrication of the customized mandibular implant using additive manufacturing process. So in that this from this diagram you can see that these are the mandibular. So sometimes maybe this will be broken while accident may happen. So during if it is broken, then doctor has to perform surgery, and they have to come with the whatever the profile of this will be there, similar profile of the implant they have to make, and they have to fix it here. For that we required whatever the design model is there. So those design, how you can get it, we have to take this image, CT scan image from the doctors, and then the doctor can send that CT scan image to the engineers, and then engineers will convert this DICOM image to the STL file format. So that's why it is very, very important. You have to get it the DICOM image of the broken or fractured area. So whatever the profile of the fractured bone is there, so similar profile will be created, and then it will be saved into the CAD model. And then once CAD model is ready, and from that CAD model it will be transmitted for the to convert into the STL file format. So that's why here I have mentioned that DICOM images are converted into the stereolithography file format using CAD/CAM software. So once this model is used for manufacturing bioimplant using rapid prototyping technique, so this can be done. After that you can go for the FEA analysis, so that proper strengthen other parameter or stress formation is there, so those are clearly visible or not, or within the permissible limit or not. So those things also will be performed, so that a proper parameter analysis can be done. So these are the some of the different design images of the mandibular, where the some of the surgery done and then the implantation was done. So these are the some of the area where the part has to be was broken, and from this area the broken bone was replaced with newly implant, and then implant was implanted here in this area after performing the surgery. So these are the some of the materials or implant design that was performed using the whatever the CT scan data was there. From that data, so that here exact shape and size of the fractured area, it can be created and it will be saved into the this position. Yes. So similarly, coming to the right side design, so you can see that there are some different type of the implant. So as per the requirement only, implant can be designed. It can be made from the poly PEEK material, or it can be made from the metallic material, so that it should be having proper strength and hardness. As we know that here a lot of pressure we are performing while doing our chewing process, so that time it should be having proper strength. For that small design metallic material customized implant are made, and it can be used for the maxillofacial surgery operation for the, and from this model itself. Now coming to the, we will discuss about the aerospace applications of additive manufacturing process. So it can be used for the making of the lightweight bracket, or it can be used for the making of the propulsions equipment will be there. Similarly, it can be used for the making of the heat exchanger. As we know that manufacturing of this component using conventional process, it is a time taking process as well as the more costly. Because of that, one can go for the additive manufacturing process. Why? Because we know that this process, this product having very complex profile or geometry. So making of those complex geometry and profile, it is very difficult using conventional manufacturing technique. But if you come using this process, so one can easily design and manufacture this kind of the product propulsion valves, heat exchangers, lightweight and functionally graded consolidated part can be also manufactured. Here table 2 is representing about the what are the AM application in defense and aerospace. So for that purpose, what are the current application will be there. So those points are mentioned here, like modeling, test unit and prototyping purpose it can be used. Similarly, the presently it was done. So nowadays even it may be advanced of that one also. So it can be fitment part or visualization model tooling. Similarly, replacement of the part and building of the component for the defense and aerospace application. While similarly, the potential future application could be there in electronics field itself. Nowadays, lot of electronics part are made from the additive manufacturing product materials, so that whatever the complex part design will be there, so those can be produced from here. So similarly, it can be used for the part printing, and that part printed will be used for the repairing in the field of battlefield itself, because from the battlefield one can't bring the whole the equipment. In that case, what are the alternative is there? So alternative is to you have to manufacture the part somewhere else, and then from there itself they can be transmitted to the where the application area will be there. Similarly, it can be used for the regenerative medicine to treat several battlefield injuries will be taking place. Similarly, printing structure using lightweight materials, having the highest strength to weight ratio material. Similarly, part with minimal waste also, because in this process wasting of the material is very minimized only. So one can go for, and they can thought of part material is very minimized. Similarly, this is one of the part which is a lightweight bracket we are calling. So here first design and optimization are performed. Otherwise, what will happen? Whatever the holes and empty area are there. So everywhere the complete solid material object could be there. But using the design optimization method. So optimization can be like lattice optimization, or can be like surface topology optimization. So here in this, especially in this case, surface topology optimization are performed. From that one can see that these are the area where the loading was not applied, so no stress was forming. So in that case, what happened, by using the additive manufacturing technique itself, there are certain software which will perform the like surface topology optimization, so that will remove the unnecessary materials from the those area where the part loading condition will be not taking place, and then it will also save the material cost and time of the printing also. Along with the lightweight, so vehicle or any body or any equipment part weight will be also minimized, and also the whatever the strength parameter requirement will be there, those strength parameter will be also intact itself. So here you have to achieve the improved functionality, and it will having the decreased weight and the lower the cost of the bracket. So these are the advantage of the. Similarly, it can be reduce the component weight, because unnecessary what are the area where the material requirement was not there. So after doing the topology optimization, this area material will be removed. So topology optimization is very, very important for understanding those concepts itself. Similarly, the maybe it may match the material specification, decrease the lead time. So these are the some of the. Similarly, it can be used for the propulsions, create more efficient rocket and satellite engines. Similarly, one can solve the problem associated with the propulsion design itself. Similarly, one can reduce the cost of the part also, because sometimes using conventional manufacturing processes, the part cost will be very high, because time taking procedure, and you have to go for multiple time of the. Similarly, some several part and then assembly has to performed. So similarly, one can use a simplified fluid management system also for the device related work. So other in the heat exchanger area, one can streamline the design and production of the heat exchanger component, and it also by using this process one can overcome the challenges which is associated with the manufacturing process using conventional method. So time taking procedure and some of the other challenges will be there, as aerospace component or heat exchanger component having the high strength and high melting temperature. So using conventional manufacturing process, it will be very difficult. But if you use the additive manufacturing processes, so it can minimize the whatever the process difficulty will be there. So that can minimize the. Similarly, it may maximize the heat transfer within the limited footprint, and also it will produce a thin and lightweight wall, so that the weight of the product will be minimized, and it will also give the surface to volume ratio, high surface to volume ratio. Now coming to the automobile application, so this can be used for the making of the outer shell of the battery or battery cover. Similarly, it can be used for the interior accessories making. Similarly, it can be used for the air conditioning duct, because sometimes the duct making itself a very complex phenomena will be there, and then maybe a costly process. Similarly, it can be used for the bumper making using additive manufacturing, or maybe some other techniques also. Similarly, it is maybe alternator mounting of the bracket. Similarly, you can use making of the suspension which bone will be there. So those also can be used for using additive manufacturing process. Similarly, this can be also used for the headlight prototyping also. So this is all about this lecture on applications of the additive manufacturing process. So in this course, I have tried to give the detail about what are the different wide variety of the applications of the additive manufacturing process. So those area I have tried to explore. In that I have discussed about the biomedical application, I have discussed about the aerospace application, automobile application, similarly tool making process. So these are the different commonly used. Similarly, also I have discussed about the making of the composite materials using the additive manufacturing process. So there are different applications applications that I have discussed. Similarly, the various what are the techniques are there, that techniques can be used for the making of the AM product itself. So I would like to thank everyone for attending this course. Thank you one and all.